Over the weekend, I've been diving kind of into this post by Anthropic that is called Building Effective Agents. This came out a few weeks ago, but I haven't really looked at it. And I just found it very interesting, and I think it could make a good introduction video to agents, how you can actually use them yourself. So what we're going to do in this video is, you can see here, Anthropic goes through like an example of how you can use an agent in different ways. So what we're gonna do is we're gonna build out all of these examples in code just to do an example. So we're gonna build out an example of the augmented LLM. We're gonna do some prompt chaining. We're gonna do some model routing. We're gonna do parallelization. So each of these categories is gonna be a new code that we're gonna test and see how they work in practice. But I think we're just gonna start on top here, just to know what Anthropic define as an agent. So they have kind of two ways to do this. So at Anthropic, we categorize these variations as agentic systems, but draw an important architectural distinction between workflows and agents. I think that's good. So they say workflows are a system where LLMs and tools are orchestrated through predefined code paths. Agents, on the other hand, are systems where LLMs dynamically direct their own processes and tool usage, maintaining control over how they accomplish tasks. So this is what we're going to look at today. I think we're just going to go through this from top to bottom. So we're going to start with building blocks, workflows, and agents. We're going to start with the first building block. That is the augmented LLM. I will be using cursor for this, so if you are using cursor too, it should be easy to follow along. I think we just want to start by just creating a simple API call. I think we're just going to use OpenAI. I'm most familiar with their tool calling. So let's just head to their documentation here on platform.openai.com. Let's just grab some information about their text generation. And what I did is I just created a text file, pasted it in here. I also did grab the full article from Anthropic, effectiveagents.md, so we have kind of the documentation if we need some extra help. I think we're going to try to do it without that, but let's just get going here. So I think the first thing we want to do is just make a simple call to OpenAI. So I'm just going to add the text and let's do a simple prompt here. So I have my OpenAI API key set in my .env. I added kind of the context here. Let's just do write a text gen call to the OpenAI API, print a response, only print content. So this should be pretty straightforward. We just want to have this base for when we start using so let's just apply this, and I think we need from load, and let's do this OS. Let's use GPT-4o, and yeah, that looks pretty good. So let's do Python augmented.py. Hopefully this works first time. Yeah. Why do programmers prefer dark mode? Because light attracts bugs. So this was just a short joke about programming. Yeah, we want to use GPT-4o. It always refers to GPT-4. I don't know why. It's a bit strange. But that is kind of our setup. Now we have code here we can work on and expand on. Like I said, I have my OpenAI key just set here. And that is basically it. We can remove this. So if we head back to the article now, what is the augmented LLM? So if you look at the schema here, you can see the basic building blocks, LLM hands with augmentations as retrieval, tools, and memory. So our current model can actively use these capabilities. So basically a simple agent that can do search queries, use tools. You can see here we have some retrieval, maybe RAG. We have tools, yeah, we have memory. So this is a pretty basic setup. I think we're just gonna create a simple call using some kind of tool, and that should be a good example of the augmented LLM, right? You can also say they talk about model context protocol. I have a lot of videos on that, so MCP. That is also an example of the augmented LLM. So let's just do this. We can continue. Let's start a new chat. Let's grab our code. But I think we want to create a file here that's called, I don't know, function call.md or something. Let's head over to the OpenAI documentation. Let's go to function calling and let's copy page. So let's grab all the documentation on function calling. Let's paste it in our MD here and add that to the context. So you can see I added an open weather API key. Yeah, you can just use this if you want to. This is just so we can make an API call. So let me just do a simple prompt here. So let's just do, I want to use the open weather API as a function call tool in our augment.py code use or add tool use so we can find the weather for a specific city. I think that should be enough because we only need to create we only need to add some code here that has kind of the tool schema set up. And yeah, it's using the get weather function. Good, that's what we need. We want to capture temperature, description, and humidity. Here is our tool schema. That looks pretty good. And GPT-4, we need to change that. We have some cleaning. Let's see now. So if we apply this, let's go over here. We really want to use GPT-4o. Same here. And let's save that. Yeah, that looks pretty good. So what we're going to do now is we have this function here that's called get weather. So this is going to call or use our open weather API. And it's going to take a city as an argument, I think. And it's going to use that to search up to find the temp, humidity, and the description of the weather from this city. Here we have our tool schema. This is calling up the function we just created, the get weather function. Get weather for a specific city. And the city name of the get weather information. So when we make the call, we want to decide a city here. So this could be Tokyo. Let's start with that. And we have Tokyo to send it back to the model. So this in theory now, when we run Python augmented.py, hopefully this finds the weather in Tokyo using our API. Yeah, today's weather in Tokyo characterized by broken clouds, temperature of 4.5 Celsius and 47% humidity. So that worked pretty good. So what we can do now, we can change Tokyo. Let's do Oslo. So I think we need to change it both places. So let's check the weather in Oslo. Again, we are using basically the same setup. Oslo is overcast, -11°C and 87% humidity. So this is how you augment the LLM. We give it some kind of action it can take or some kind of tool. In this case, it was the tool to actually get the weather here. There are some more things we can do to make it more reliable. We could add, say, like a system here. So to do that, I think we just create a new role. Yeah, system role. You're a helpful assistant that can get weather information. Use the tool or something like this to get the information. So we can add a system message here if we are struggling the model to actually calling this. So I think we need to add this in both places like this. And this should also work now, I think. It doesn't make a big difference, but I like to have system messages, right? And in the system message, we can also specify something like return the response as a poem or something like this. And this could be, we can do that here too. Return the response as a poem, right? So now we should probably get the response from the weather in Oslo as a poem, right? Yeah, you can see. In Oslo's embrace, quite cold, great story. So this is how we can change up things by just using a system role here. So always think of that if you have some specific requirement of the output. So that is basically how you can augment an LLM. So this is how Anthropic is thinking about too. We can of course add memory to this. We can add query, RAG results, and mix all of these together. But I think the tool calling kind of represents what they were thinking about here. Next up, we have something called prompt chaining. Prompt chaining decomposes a task into a sequence of steps, where each LLM call processes the output from the previous one. You can add programmatic checks, see a gate, so we have a gate here. And when you use this workflow, ideal for situations where the task can easily and cleanly decompose into fixed subtasks. Main goal is to trade off latency for higher accuracy, making each LLM call an easier task. So we have some examples. So basically, you can see we have a call, we get an output from this LLM. So we're gonna decide, is the output okay? If it's good, or if we get an output, we should pass this to a new call, and so on. So this is like prompt chaining. So let's just set up a simple prompt chain here, and you can kind of see how this works. To do some chain prompting, I thought we could just continue on the code we have, but I want to turn it into a function. So I'm just gonna turn this into a function named OpenAI tool call, where the argument should be a string with a city name. Because I think that's just easier if we have a function and then we can kind of manipulate the responses. So let's see what we get here. Let me take a quick look. Return, yeah, that looks good. So now we just need a city name as the argument. So what's the weather like in city today? Yeah, so let's just do probably something like print. Let's do Oslo. Let's see if this works. So now we're just gonna send in Oslo and we're gonna print the response. Okay, that looks pretty good. But now I kind of want to store this in a value. So let's call this weather1 or something. And we can do this print, and this should work too. So now we're just gonna store this in this value here. And here now we can kind of use this in our next API call, since this has captured the weather from the first API call. And that is kind of what I mean by chain prompting. So if we create a new function here now, let me just come up with a simple text generation function here. So let's just create a simple text generation function that uses the OpenAI API as an argument. So let's just use cursor to create this for us. And now you can see we have a generate text. This takes the prompt as an argument. We call GPT-4o. We don't need a system message here. But now we are gonna do something else here. So let me just show you. So let's just bring this weather1 down here. And now we can do like an F string prompt, right? So let's just do something, compare weather, and we can do equals, and let's do generate text. But now let's do like an F string here. And we can do Oslo, and we can do weather. But let's compare, not Tokyo, compare the weather in Oslo now against the average or something. And we can do something like, let's bring this to the front. So let's do weather in Oslo now, right? Compare this weather in Oslo now against the average weather in Oslo. So now you can see we take the response from our first call, that is gonna be just to get the weather, and we're gonna feed that into a new call that is gonna use like an F string to, we have the live weather in Oslo. Now we can compare this, right? So if we run this now, hopefully we will yeah, get a response. Okay, so now you can kind of see to compare the weather with the average. You can see The average is around -7 to -1. Now it's -7.8. Conditions that are typical, slightly colder than the average. Humidity of 41 is quite low for Oslo in the winter. So you can see we kind of use the response from the tool call into a new prompt that kind of compares the weather with the averages that comes from the original training of OpenAI's GPT-4o, right? And we can just continue. Now we could take this variable and use it in a new prompt so we can chain them together. And this could be very helpful because sometimes the response you get here is what you need to solve the next problem. So I think this is what Anthropic is talking about when they mean prompt chaining. We want some initial answer. We need to pass this because we need answer from 1 to answer 2. We need answer from 2 and 1 to answer 3. And yeah, so and so on, right? I'm gonna be making a video where we're gonna do loads of prompt chaining with different AI agents soon. So look out for that. Yeah, I think that example kind of covers prompt chaining. Now we want to go on to routing. So I thought we can do this. Let's see how they talk about this. So routing classifies an input and directs it to a specific follow-up task. This workflow allows for separation of concerns, building more specialized prompts. Without this workflow, optimizing for one kind of input can hurt performance of other inputs, right? When to use this workflow, routing works well for complex tasks, distinct categories, okay. Direction different types of customer services, routing easy and common question to smaller models. I think we're gonna do a model routing example. So how are we gonna do this? I think we need to create a router that kind of decides, is this call gonna go to GPT-4o mini or maybe O1 mini or GPT-4o, we'll see. So based on the input, we need to create some kind of router that decides, yeah, what model should answer this, and then out. So I think that is kind of what I mean by routing, but they're a bit different. You can have different prompts you can route to. We can maybe do that too, let's see. So yeah, let's head back to Cursor and do this example. Just to make this a bit more easy, let's just use what we have here. So we want to keep the generate text function, but I think we want to remove the get weather and tool call function. So let's start with this generate text function. I think I'm going to call it router agent or something like this. So this is just going to take in a prompt that comes from, yeah, we can fix that afterwards. So this is going to be the router agent. So I think we want to give this a system role maybe. So let's do, yeah, a system role for this. I'm going to come up with a system role here because this is quite important. We need to decide what kind of model is going to be the router to. Let me think 2 seconds about this and how we can do that. So now we're just going to do the router agent is to send the user input to the correct model. So yeah, you can see here I changed up the system message. You are an LLM router agent. You are to route the user input to the correct model. Or agent was my ID here. I'm just going to call it agent. It doesn't matter too much. So you can see we have some parameters to consider when to route the user's query. Do the user input require extensive reasoning? If yes, send this to the reasoning agent. Math or coding? Yes, send it to the reasoning agent. Does the user request just a simple conversational answer? Send it to the conversational agent. So it's a pretty basic setup. So now we just need to create 2 different agents. So we need a def reasoning agent, right? So this should be pretty straightforward. Yeah, GPT-4o for that. And for the def conversational agent, we can pretty much do the same. So let's do GPT-4o mini for this one. Is that the correct? I think so. So now we kind of have a mini that is cheaper and faster for the conversational requests. And we have GPT-4o that is the reasoning agent. Maybe that could have been like 03 or 01. That would have been a better choice, but yeah, just let's keep it like this for the example's sake. So now we're gonna start sending, the prompt is gonna go to this agent that is gonna decide, we need to add some code here, where to go. So I think I'm just gonna request Claude to help us set this up. So I'm just gonna do the prompt. We need a router agent to take the user input first. Then we decide where to route the question next. The router agent should just decide where the request go. It shouldn't answer it. So if the user input is hello, the agent should send this to the conversational agent and so on. Then the user should only see the output from the conversational agent and get the answer back from this agent. So let's implement this. Okay, so see, I think this is gonna be pretty straightforward. Yeah, I had a suspicion that it was gonna change up my system prompt. So this is just gonna relook at response should be reasoning if it's one of those, and conversational if the response is this. We can just apply this and I can kind of show you here what I meant. So now we're just gonna have like so if route 2 is reasoning, we're gonna send it to this. If not, we're gonna send it to the conversational agent. So let's do a quick test here. So let's just start by doing like the router agents. We're gonna send in just hello, right? So hopefully now we will only get the response from GPT-4o mini. That's gonna be the conversational agent. Yeah, you can see we routed to conversational agent. Hello, how can I help you today? Let's do a coding question here. So let's put in a different argument here. So now let's write a Python code to calculate the area of a circle. So hopefully now this should mean we are routing to the other agent. Yeah, a reasoning agent. And that is kind of how we set this up. We should now get like a Python code to calculate the, yeah. So that is pretty straightforward too, but it can be powerful because we could save money, right? Let's say we have this in a loop. Sometimes we get the answer from Mini if it's just conversational, but if we need more power, we get it from the reasoning agent. The thing is we lose latency because everything has to go. Now we use GPT-4, that was a bit slow, but that's fine. So everything has to go through the router agent, and we need to be sure that this is able to make the right decision. But it shouldn't be that hard to evaluate that. And of course, this is gonna be more expensive too, since we need to make a additional query to the API. But if you look at what Anthropic said here, so this could work well in like, yeah, picking models and different types of customer survey queries. So sometimes we route to a prompt about refunding request, technical support. So what we didn't do here is like I said, instead of having conversational agents, we could have different prompts. So this router kind of decide what input should be, what kind of prompt this input should be sent to. That is also something you can do, and it's not so hard to set up. But I think this shows how we can create a simple router that divert the input where it's most likely to get the best or the cheapest or most optimized response. The next workflow is gonna be parallelization. So here you can see LLMs can sometimes work simultaneously on a task and have the outputs aggregated programmatically. So what we're gonna do here is sectioning, I think. We could do breaking a task into independent subtasks run in parallel. They also suggest voting, so this is running the same task multiple times to get different outputs. I think we're gonna do sectioning, so we're gonna do, I think we can do like an async call, do two prompts in parallel to get two different answers to kind of, yeah, let's say we ask for the weather here, we ask for some kind of other stuff in LLM call 2. We aggregate all this into, yeah, some kind of prompt, and then we can use both results to get the output. So when to use this workflow, parallelization are effective, divided in subtasks that can be parallelized for speed or perspectives, right? So yeah, we have some examples of how we can use sectioning and how we can use voting. It shouldn't be too hard to set up. If you use Python, we can just do like a async call here, I think. So let's head over to Cursor and try to set this up. So in our code here, I just went back to one simple call here. So we're just gonna use the LLM agent function that takes a prompt in and gives a response back. So we can use this, maybe we need to add one more function, but let's show you, I wanna show you some kind of workflow we can do in Cursor here. So we have our code here. Remember, we added the full effective agent article here in our documents. So if we add this to our context here, right, effective agents.md. So let me do a prompt here to see if Cursor can create this parallelization call for us. The prompt here is gonna be, I want to create a parallelization LLM setup with 2 agents. I think I meant 3 agents. The first agent should answer on one specific question. The second should answer another in parallel to optimize for speed. Feed both of these answers to a third agent that takes this aggregate and gives a final answer. Print all answers along the way, implement this into my code. So now this is probably gonna create 3 different functions and we're gonna run them in async, right? Perfect, that's what I want to see. We have LLM agent, parallelization, LLM processing, and yeah, that looks pretty good. So let's add this to our code. It keeps referring back to GPT-4. It's very annoying. But let's do GPT-4o. So this is just a basic function that takes a prompt. So we have the processing, agent 1, 2, 3, system 1 and 2, analytical, and we have a creative assistant. So here you can see we run this in a thread. To do this in parallel, we get the both results. We feed those in with an F string here. So we get the analytical perspective, the creative perspective. Then we want a balanced, complete answer from both perspectives. Then we synthesize this into one answer. So we return all of this. Okay, that looks pretty good. So let's run this and see what we get back here. And also let's add some prints here, right? We get that, I didn't see that. So we can actually see what happens. So let me open this. So let's do Python augmented. So hopefully this should be pretty quick now because we are running this in parallel. So yeah, we don't have any along the way here. So we're just gonna get the final output. We're not streaming this, but let's see now how long this takes. Okay, so if we go further up here now, you can see we have the analytical response, perfect. We have that angle, we have the creative response angle, and finally we have the final synthesis. So here we take and aggregate both different angles from both the first agents, and we kind of get like a final answer that take both angles into consideration. So this parallelization can be very powerful, but of course you make more calls, but you could also save time by doing it in parallel instead of serializing this. So yeah, I use this sometimes. Can be very effective if you need different angles, but there's a bunch of things you can do with this. Like they said, you can run multiple prompts with the same task to get diverse outputs. So there's a lot of opportunity and flexibility while running this system. If you go back to our article now, the next part is gonna be Orchestrator-workers. So this is a bit different than we've done before. So in the Orchestrator-workers workflow, a central LLM dynamically breaks down tasks and delegates them to the worker LLMs and synthesizes the results. So this is almost like we did before. We have like a central LLM that takes in the prompt. It kind of knows what worker it has access to. The idea is that the orchestrator decides where the call should go, and these agents are going to do the task based on the information it gets from the orchestrator, and it's going to be brought back down and synthesized after we get a response from these LLMs. So this should be pretty easy to set up. I think we're just going to do 2 workers. So when to use this, well suited for complex tasks where you can't predict the subtasks needed, right? In coding, for example, the number of files needed to be changed, the nature of change in each file is likely dependent on the task. We have some examples. Coding products can make complex changes to multiple files. search tasks that involve gathering, analyzing information from multiple sources for possible relevant information. I would say it's pretty similar to what we looked at here for routing, but this time we're not gonna just route based on what we have here. We're gonna delegate this more into tasks, right? So again, we're just gonna go back to our simple code with our API call here with the LLM agent function. So we're just gonna add again our effective agents. I think we're just gonna try the prompt. I want to create a workflow with 2 orchestrator workers, implement this. So here we should look at the content from our effective agents article. And again, this shouldn't be too hard for Cursor to figure out. I think it's going to be pretty straightforward. We probably need some worker IDs or something like this. So let's just see how it wants to set this up. Okay, so let's add this to our code here. So I'm just going to do it like this, and we can blow this up a bit. So here you can see now we have a function called Orchestrator that takes a task in. So this is you are an orchestrator that breaks down task into subtask. Analyze the following task, break it down to 2 different subtasks that can be handled by workers. Return the subtask in clear numbered format. So we have the task here, right? And again, we want to use 4.0. And you can see we have some subtasks. We're going to assign this to different workers. So we have worker 1 and worker 2, right? Synthesize these workers, return to a final response. We're going to bring the result back to our orchestrator agent. We want to use GPT-4 for that. In the worker function, you are worker and we give them an ID. Given these subtasks, focus on completing this worker ID, right? Subtask, that's going to be given from the orchestrator. Great. And that should be pretty much it. So let's see how we give our task now. I'm just going to figure that out. So I think we can just do like final result. Yeah, that looks pretty good. What are the implications of AI in healthcare? Let's come up with a different task that could be a bit more interesting. So let's just try. I need to create a software in Python that can add 2 integers and sell this to a client. Very basic task. So let's see what happens now if we run this. So hopefully now we will delegate this to 2 different agents. I didn't add any prints, so we probably won't see that. We might go back to add some print statement. Or just wait a bit. Let's add those print statements. That's a bit interesting to kind of see. Again, it's stuck on GPT-4. It's very annoying. But yeah, now we have some prints here. That looks a bit better. So let's bring this back. Let's run this. So hopefully now we can actually see what the worker is answered. So here we have the subtask. So one task is develop a Python program that takes 2 integers as an input, calculate and display the result. Oh, that was a bit quick. And the other subtask is gonna be to prepare a sales strategy to market software to potential clients. It's a bit strange task, but you can see the worker 1 result was to write the Python code to add 2 integers. Good job. And yeah, we have some explanation. And we have the worker 2 result to prepare an effective sales and marketing strategy. Develop in subtask 1. We will do the following steps. Okay, great. And the final response is developing and marketing of a basic Python calculation tool. So we have the software development, we have the marketing strategy, pitch, sales pitch, conclusion. So yeah, perfect. That's exactly what we wanted. So our central agent here kind of wrote out the subtask. That is an important part. It delegated these subtasks to 2 workers. The workers executed these tasks, sent information back to the orchestrator that then synthesized this into one answer and gave a final response to the user with the business plan and kind of the software creation. So yeah, well done. Not so hard to set up, but can be very effective. So like I said previous in this video, I think I have a plan to create a kind of big project where we have like tens, maybe 20 different agent that's going to work on like the same task. I think it's going to be pretty interesting. But yeah, I think that's it for the Orchestrator-worker workflow. It's pretty interesting. And the final one is going to be the Evaluator-optimizer. This is something that's also pretty interesting. It's almost like LLM as a judge or something like that. So let's take a look at this. This workflow is also something I really like. So here we kind of, one LLM calls generate a response while the other provides evaluation in a feedback in a loop. So basically you can think of this like, I think we're gonna do LLM1 creates a Python code. The evaluator looks at it and says, not good enough. Send it back with feedback. Do this to improve this. It tries again. No. It tries again. Yeah, now you're good. Then it's accepted and it's gonna be sent out to the user or something like this. This workflow is particularly effective when you have a clear evaluation criteria. So this is only useful when you have something that you can evaluate, right? It's really hard to evaluate an essay or something like this, but like some kind of code or something could be easier. So here we have translation nuances that the translation LLM might not capture initially. Complex search tasks that require multiple rounds of searching and analysis to gather information. So one thing that can be a bit difficult here is the evaluator tends to often agree. So it could be very easy to accept the result. But let's see if we can get it at least to go in one loop. So I think we're just gonna, I went back, we just have a call here to the OpenAI API. And I want to do the prompt. I want to create a workflow with an Evaluator-optimizer. We should evaluate the quality of a Python code for approval. If the eval fails, retry until it passes. Implement this. So again, it's not that hard to set up, but you might have to work a bit on the system prompts here and what kind of model you use to evaluate, because sometimes it's not so strict. It just said, yeah, that's good. Looks good to me. Let's just get it out of here. So let's take a look at the suggestion from Claude here. We have an evaluator code function. That's fine. We have an optimize code function. We have an LLM agent for iterations in a loop. I would just want to watch this a bit bigger here. Again, it's using GPT-4. It's very annoying. I guess we could use GPT-4 for the evaluation, but let's use 4.0, right? So let's have a look here. So this, you're a senior developer code reviewer, evaluate a given Python code for quality, return a JSON with passed boolean or feedback string, okay. Ooh, that smells like trouble, but let's try it. Please evaluate this code. We feed in the code here. That looks good. Optimize code, you're a Python expert, improve the code given based on the feedback. Okay. LLM agent, you're a Python dev. So this is the first. So this is gonna write, it's gonna send it to the evaluator and we can improve it, right? So let's just try this out and see how this setup works. So we can just do, yeah, let's just use this. This is fine. So this is gonna create a function that calculates the Fibonacci sequence. Okay. I think we want to add some more prints too. Add some more prints to get the full workflow overview. Yeah, now we can add the initial code. We can print that, the feedback, and yeah. So it's a bit more interesting when we run this in the terminal. Again, we have to do the 4.0. Very annoying. Yeah, that looks pretty good. So let's try this now. So remember, we're gonna try to write a code for a Fibonacci sequence, and hopefully we can see initial code generation. So let's see how this goes. Okay, we wrote some code. We're gonna evaluate it. It's probably gonna get passed. Yeah, we got some trouble with the JSON. I don't really like that. I think it's a bit yeah, it's gonna fail a lot with the JSON. Resolve this, because the formatting is gonna be troublesome here if we rely on JSON. But let's give it one more shot. So let's try again. We're gonna write the code. We're gonna evaluate it. It looks pretty good, to be honest. The code is correct. Code approved. Returning the final version. Yeah, that was pretty good. That worked, but let's, like I said, it's gonna be quite kind here. But let's instruct the developer to write bad code. So let's just add in, the code should be test the eval function, so write code with bad practices. So let's see this time if we can pass this the first time. So now we kind of instruct our developer to write bad code. I don't know if it's gonna work, but let's see. Yeah, it looks less. Okay, so it failed. That's good. So the iteration is a bit fast. We can go over this. Okay, so we got one iteration at least. So this was the initial code, right? And on the first evaluation, the usage of eval is problematic here, risky and inefficient. So the performance hampers passed, no. Then we send this to optimize the code based on feedback. Here is the improved version, good. And it goes back to the eval. The code is well written, efficient and secure, best practices, perfect, approved, returning the final evaluation. So yeah, that is basically what we want to see. Yeah, there's a bunch of stuff we can do here, but I think this proves the point. First iteration failed. We went back, sent that with our problems. We wrote a better code, optimized based on the issues we had on the code. And on the second attempt, we got this approved. So this is kind of the idea behind this evaluator, LLM as a judge. You can call it what you want, but basically we get stuck in a loop here until the eval agent thinks this is good and we can return this. So yeah, pretty interesting. So yeah, I think that was basically the last workflow they had here. They have something about agents here, so you can see agents are emerging in production as LLMs mature in key capabilities, understanding complex inputs, engaging in reasoning, planning, using tools reliably, recovering from errors. Agents begin the work with either a command from or interactive discussion with the human user. And they have an example here of an autonomous agent. So here we kind of have a human, we have an LLM call, we have an action and a feedback and an environment and when to stop, right? So I'm not going to do this example, but they have like a simple summary here. When to use agent. Agents can be used for open-ended problems where it's difficult or impossible to predict the required number of steps, where you can't hardcore a fixed path. The LLM will potentially operate on many turns. You must have some level of trust in the decision making. Agents' autonomy makes them ideal for scaling tasks in trusted environments. The autonomous nature of agents means higher cost, potential for compounding errors. If it goes down the wrong path, you can just compound on this. So we recommend testing, extensive testing in sandboxed environments along with appropriate guardrails. Yeah, that's a good idea. So do sandbox testing, don't just put this in production. I would do a lot of testing, but I really appreciate Anthropic wrote up this guide because it can be really hard to know when to use this. It's very easy to fall in this trap that they talk about here. Success in the LLM space isn't about building the most sophisticated system. It's about building the right system for your needs. Start with simple prompt, optimize them with comprehensive evaluation, and add multi-step agentic system only when the simple solution falls short. So there's no point in building like a very sophisticated evaluator system if you're just gonna ask how to write a Python code to add 2 integers. Then you can just do that in one call, right? So yeah, hope you enjoyed this. Hope you learned something from this. I'm going to be covering a lot of different AI agent stuff in 2025. New models, everything. We're going to do some projects I have in mind. So yeah, stay tuned for this. Like I said, hope you enjoyed this video. Hope you learned something practical that you can start experimenting with. So yeah, thank you for your support and hopefully I'll see you again in my next video. Bye bye.